Hello. Today we shall discuss about the polarization, that is the effect of polarization in the ionic character or in the covalent character of a chemical bond. So let us first know that what is polarization. We know that an electrovalent bond is a kind of electrostatic force of attraction in between two oppositely charged ions, that is the cations and anions. And when the cations and anions come close to each other for the formation of bond in between them, two oppositely charged forces come into play. These two forces are first the force of attraction in between the positively charged ion and the electron cloud of the anion, and the other force which is acting in between the two oppositely charged ions is the repulsion in between the positively charged nuclei of the two ions, that is cations and anions. And as a result of this polarization, as a result of this two type of opposite force, the shape of the anion gets distorted, and this distortion or the deformation in the shape of the anion, that is called as polarization. And the tendency of the anion to get polarized or to get deformed is known as polarizability. And the power of the cation to deform the anion or to deform the shape of the anion is known as its polarizing power. As a result of this polarization, there is some sharing of electron in between the two ions, as a result of which the covalent character in the molecule arises, and this covalent character in the molecule is directly proportional to the polarization. That is, greater is the polarization, greater will be the covalent character in the molecule, or lesser will be the ionic character of the molecule. This can be presented like this. Suppose this is your cation and this is your anion. These two are coming towards each other for the formation of the bond. Then, as a result of two oppositely charged forces, the shape of the anion gets distorted, and this deformation in the shape of the anion, that is known as polarization. So polarization is the phenomena in which the shape of the anion is deformed or distorted during the formation of electrovalent bond between cation and anion, and this is on account of the two oppositely charged forces, and this is on account of first the attraction of the cation or attraction of the electron cloud of anion by positively charged anion cation and second, the repulsive forces acting in between nuclei of two ions. So this is your polarization, and the tendency of the anion to get deformed, that is called as polarizability, while the tendency of the cation to polarize the anion is called as its polarizing power. The tendency of anion to get deformed is known as polarizability. And the power of the cation to deform the shape of the anion is known as its polarizing power. Polarizing power. And this polarization is directly proportional to covalent character in the molecule. Polarization is directly related with the covalent character. That is, greater is the polarization, greater will be covalent character of the molecule. Now, this polarizing power of the cation is directly proportional to the charge of the ions and is inversely proportional to the square of the radius of the ions. This polarizing power of cation, this is directly proportional to charge of the ions, charge on the ion, and is inversely proportional to square of the radius of the ion. And this is represented by phi. So phi represents the polarizing power of the cation. Now let us see that what are the factors which affect the polarization, or the covalent character of the molecule, or the ionic character of the molecule during the formation of electrovalent bond or ionic bond. So now we shall study factors affecting polarization. This polarization is directly proportional to the charge on the ion. Polarization is directly proportional to charge of the cation. That is, greater is the charge on the cation, greater will be its polarizing power. So in case of polarization, you can write also the polarizing power of cation. Polarizing power of cation. This is directly proportional to the charge of the cation. So let us take some examples on this. Suppose it is your NaCl, BeCl2, AlCl3. These are the three molecules in which the anions are same, but the cations are different. So this sodium has got one positive charge. Here beryllium has got two positive charge. Here aluminum has got three positive charge. So the maximum polarizing power will be in aluminum ion, and therefore the covalent character in aluminum chloride will be maximum. In NaCl it will be least, and in BeCl2 it will be in between these two. So this is your increasing order of polarization. And if the polarization increases, then this will be increasing order of covalent character. And we know that electrovalent compounds have higher melting and boiling point in comparison to that of the covalent compounds. Therefore, this will be decreasing order of melting point, and greater is the covalent character, lesser will be the solubility in water. So this will be decreasing order of solubility in water. And also you can write increasing order of solubility in organic solvent. Now another factor which affects the polarization is the size of the cation. Size of the cation. The size of cation is inversely proportional to polarization. Or polarizing power of cation. That is, smaller is the size of the cation, greater will be polarization power, and greater is the polarization power or greater will be polarization, greater will be covalent character or lesser will be ionic character. As for example, suppose it is BeF2, MgF2, CaF2, beryllium, magnesium, calcium, SrF2, and BaF2. Then, as we know that in a particular group, as we go down the group, the size of the atom as well as the ion increases. This beryllium, magnesium, calcium, strontium, and barium all belong to same group. So this will be your decreasing order of polarization. And when the polarization will be decreasing, they will be decreasing in covalent character. And when the covalent character will decrease, the melting point will also decrease. Covalent character will decrease, melting point will increase. So this will be your increasing order of melting point. Likewise, if we take the two cations of the same element having different cationic charges, like SnCl2 and SnCl4, this carries 2 positive charge, this carries 4 positive charge. So greater is the positive charge on the cation, greater will be polarizing power, more will be the covalent character, or lesser will be the ionic character. So on this basis, this is your more covalent and this will be more ionic. Similarly, the another factor which affects the polarization, that is the size of the anion. The size of the anion is directly proportional to polarization, or here it will be polarizability. Polarizability of anion. When we shall talk about the cation, then it will be its polarizing power, and when we shall talk about the size of the anion or the factor of the anion, then it will be the polarizability of the anion, because the tendency of the anion to get deformed, that is known as polarizability. And greater is the polarizability, more will be the covalent character, and more will be the covalent character, lesser will be solubility in water. So suppose it is AgCl, AgBr, and AgI. So this will be increasing size of anion, and also this will be increasing covalent character, decreasing solubility in water, solubility in water. Similarly, if we compare NiCl, LiBr, and LiI, this will be increasing order of polarization, covalent character, and when covalent character will increase, the solubility in the water will decrease, melting point will also decrease, but the solubility in the organic solvent will increase. Now another factor which affects the polarization are the polarizability of the anion, that is the configuration of outer configuration of cation, which you may also say the valence shell electronic configuration of the cation. The cation may have inert gas electronic configuration of its valence shell, or they may have pseudo inert gas configuration. So in case of inert gas valence shell configuration, inert gas valence shell configuration means S2P6 configuration. Then the polarization will be less. And when polarization is less, ionic character is more. Another configuration may be pseudo inert gas configuration. Pseudo inert gas configuration. In this case, the polarization will be more. Polarization is more, then covalent character will be more. And when the covalent character will be more, then the solubility in water will be less. Melting point will also be less. Now, what is mean by pseudo inert configuration? Pseudo inert gas configuration. Pseudo inert gas configuration means its valence shell is completely saturated. Valence shell is completely saturated. Complete saturation means whatever maximum number of electrons that should be present in that shell is present, but it is not sp26, but it is not S2P6. Now let us take the example. Suppose it is sodium chloride. In sodium chloride, Na plus has configuration 1s2, 2s2, 2p6. This is your inert gas configuration. But if you consider CuCl, then Cu plus has configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. This is your M shell, and M shell can have maximum of 18 electrons, that is completely saturated. So this configuration will be your pseudo inert gas. And if it is pseudo inert gas configuration, then in this case the polarization will be more. And if polarization is more, then covalent character will be more. The ionic character will be less. Thus, CuCl will have greater polarization NaCl will have less polarization. Therefore, CuCl is covalent, soluble in organic solvent, insoluble in water, and NaCl, this will be ionic, soluble in water, insoluble in organic solvent. So this is all about polarization.